This problem is from GATE 2021 Mechanical Engineering paper of Set 2. The question says, which of the following is responsible for eddy viscosity or turbulent viscosity in a turbulent boundary layer on a flat plate? So 4 options we are given here and we need to choose the correct option for the stress that is responsible for eddy viscosity. Let's first see the diagram of turbulent boundary layer over a flat plate. Now this diagram represents the flow over a flat plate. So we have 3 regions: laminar region, the transition region and the turbulent region. In laminar region, the flow is smooth. That means it flows over one layer over another. In transition region, the swirling just starts. That means it is not completely turbulent here. The flow has just started to swirl. But when the flow reaches in the turbulent region, what happens here is a lot of eddies and swirls will be formed here like this. So lots of eddies will be responsible for turbulent viscosity. These swirls or these eddies are responsible for eddy viscosity or the turbulent viscosity in the turbulent region. Now we'll go through all the stresses listed here and we'll see which stress is responsible for eddy viscosity or the turbulent viscosity in the turbulent region on the flow over a flat plate. Let me tell you the correct answer in the beginning itself. It's Reynolds stress. Although the interesting thing here to note is all the stresses listed here is responsible for eddy viscosity, but not on turbulent boundary layer on a flat plate. That is only Reynolds stress. The Reynolds stress theorem is used for the calculation of turbulent boundary layer on a flat plate. Now let's see all the stresses one by one. The first is Nikuradse stress. In his experiment, Nikuradse's experiment were on wall friction in pipe flow. In his experiment, he used a variable called sand roughness with different grain size. So he used to stick it here on the pipe in his experiment and the flow will be allowed to pass through it, and then when it becomes eddy, that measurement is done by Nikuradse and the stress was called Nikuradse stress. Now before discussing Reynolds stress, let's see Buzyn's and Prandtl stress. Now Buzyn's proposed a stress strain rate relation for a time average flow of a one dimension nature of the form tau xy plus yr is equal to rho kinematic viscosity, this is turbulent viscosity, dou ux divided by dou y. Vt here is turbulent viscosity. Now evidently this turbulent viscosity is the property of turbulence and not that of fluid. Prandtl was the first to propose means of estimating mu t, the turbulent viscosity, and that was known as mixing length model. So Prandtl proposed a model called mixing length model, which again give rise to Prandtl stress. One thing to note here is both are responsible for turbulent viscosity or eddy viscosity, but not over a flat plate. Now let's define Reynolds stress. Now the Reynolds stress tensor for a homogeneous fluid can be written as tau ij is equal to rho ui uj mean. Here you see Reynolds stress, this tau ij is Reynolds stress tensor, rho is the density of homogeneous fluid, ui dash and uj dash, these are the fluctuation in velocity in x and y direction respectively, or I and j direction respectively. So ui, that means velocity in x direction, can be written as the mean velocity in that direction ui bar plus ui dash, that is fluctuation in x direction. Similarly for y direction also we can write in the same manner. Now let's go back to the flow over flat plate and observe the turbulent boundary layer. Because of this swirling, there is fluctuation in velocity in x as well as in y direction, that is ui dash and uj dash. Also the mean velocity is taken ui bar and uj bar in x and y direction respectively. So you see here, because of this Reynolds stress, the turbulent viscosity or the eddy viscosity is generated, or rather we can say turbulent stress theorem is used to determine the eddy viscosity and turbulent viscosity on the flow over a flat plate. So from the given explanation, we can say that option B is the correct answer. So to conclude, I can say that turbulence is one of the most interesting, most vast, toughest and most mysterious topic to study in fluid dynamics. For more detailed explanation on turbulence viscosity, check out the lecture by Dr. Suman Chakravarti from IIT Kharagpur on turbulence modeling. I hope I was able to clear your doubt. Have a nice day. Thank you.